Hi students, let's look at this question here, which is on binomial distribution, taken from the H2 Math A-Level paper 2, question 7, paper from the year 2019. So a company produces drinking mugs. It is known that on average 8% of the mugs are faulty. Each day the quality manager collects 50 mugs at random and checks them. The number of faulty mugs found is the random variable f. State in context of the question, two assumptions needed to model f by a binomial distribution. I think this is pretty okay. So it's just the assumption needed, right? The two assumptions needed. So the first thing is obviously each mark would have a constant faulty rate of 8%. So meaning if you choose mark number 1, randomly pick one and the other one, each of it will have 8% of faulty rate, right? And also you want the case where each mark is independent of each other. So like say if you have one consignment of marks, if you pick 50 of it, you don't want them to be like clumped together, or say if say one consignment, like around one area everything is damaged, like let's say damage, the marks are like crushed by some item in the warehouse and whatnot, right? So you do not want that to happen. So essentially, because you have to be like independent of each other, because once you have like one part of the consignment being damaged, then meaning that mark which is next to which, they are sort of like dependent, not really entirely independent, right? So that's the idea there. So you want it to be independent of each other, right? So state in context of the question, two assumption needed. So I'm going to write this down. I think that's pretty okay. So let's look at the second part. You're now given that f can be modeled by a binomial distribution. Find the probability that on a randomly chosen day, at least 7 faulty marks are found. Okay, let's see how to do this. I think f is already defined as a number of faulty marks out of 50. So we don't really need to define it. Here will be f, binomial, f. So any given day, there are 50 marks being chosen, and each one being faulty is 8%, right? So find the probability that on a random chosen at least 7 marks. So the required probability is just PF at least 7. Just key in calculator. So obviously our calculator is CDF, so we need to change to lesser than. So PF at most 6. Okay, so this case, just be mindful of the sign there. Do not put 7 here. Okay, so if you are not too sure, just remember to draw the number line. So like 7, 8, 6. So always start counting from 0 to 50 here. So what we want is this guy here. Okay, PF at least 7. So we take 100%, which is here, 1 minus of this guy here, which is PF at most 6. Okay, just remember that. So that's that. Key in calculator, we'll see what we get here. So what I'm gonna do is go to stats, second distribution, and then I'll go to binomial CDF. Right, we have 50, then we have 6 trials, 0.086 CDF. Just key this in. So 1 minus of this over here, we'll get 0.10187. So this is 0.10187, 0.102 3SF. Okay, so let's look at part 3. Part 3 is the number of faulty marks produced each day is independent of other days. So find the probability that in a random chosen working week of 5 days, at least 7 faulty marks are found on no more than 2 days. So this is the event, the condition, at least 7 marks found faulty. Okay, so this is the condition out of 5 working days. All right, no more than 2 days. So let's try and understand this part here, compartmentalize it. I'm going to let x be the number of, so essentially let x be the number of days that have the condition here. This is the condition, at least 7 faulty marks. Okay, out of 5 days. That is the main thing. So just understand that the condition that you need to satisfy is this. So this case here, X, we have binomial, we have 5 days. Each day, success rate will just follow this, right? So I would suggest you use the 5SF 0.101. So this is 0.10187. Okay, so this is the essentially the success rate that you are looking at each day. At least 1 is at least 740 days. So the required probability, what we have is px. We need it to be no more than 2 days. No more than 2 days meaning at most 2, right? So out of 5 days, no more than 2 means at most 2. So I'm going to key this into calculator here. So second distribution, then we go to binomial CDF. Then this case still will be 5, and the success rate will be 0.10187, then no more than 2. So I'm using this keying calculator, 0.99097. So this case still what we get is 0.991 3SF. Okay, so that is part 3. This is part 3. Okay. So let's look at part 4. The company also makes saucers. The number of faulty saucers also follow a binomial distribution. The probability that a saucer is faulty is P, right? Faults on saucers are independent of faults on marks. Okay? So meaning the marks and no saucer, they are also independent of each other. So write down an expression in terms of P for the probability that in a random sample of 10 saucers, exactly 2 are faulty. Great. I think this is quite okay. Firstly, I'm going to let Y be the number of faulty saucers out of 10. So here what we get is P Y binomial 10 and P. Exactly 2 are faulty, meaning P required probability expression required. Okay, it's just PY goes to 2. I think not an issue, so it's 10 choose 2. Then P success rate and non-success rate. So success events happens twice, so it's to the power of 2. The non-success events happens 8 times 10 minus 2, which is 8. Okay, so this you could just refer to MF26 to write this down if you want to. So just keying 10 choose 2. From the calculator, it gives us 45. So this is 45. This is P square 1 minus P 8. So this is the expression required. Let's look at part 5. So the marks and saucers are sold in set of 2 randomly chosen marks and 2 randomly chosen saucer. The probability that a set contains at most 140 item is 0.97. Write down an equation satisfied by P, hence find the value of P. Okay, great. I think because the idea now is sold in a set. One set is 2 independent marks and 2 saucers. Right? This is one set. And we are told that at most 140, the probability is 97%. So what we're going to do is understand that is either 140 out of the 4 items or 040. Okay? Actually, I'm just going to draw the tree diagram. You don't really need to draw it out because I need to explain, so I'll just draw the tree diagram out so that you can see clearly what's going on. All right. But in the exam, if you're not too sure, because it's just either you're faulty or not, right? So essentially what you're looking at is 2 to the power of 4 branches, right? Tree diagram. So I'm just going to draw it out. So here we got mark 1, mark 2, saucer 1 and saucer 2. So mark 1 is either you're faulty or you're non-faulty. Faulty and you're non-faulty. What we need to do is actually just to find out which are the branches which we need to add up to give us 97%. So I'm going to fill all this up. This is the tree diagram. Then we know that for a mark to be faulty, it will be 8%, so 0.08. This will be 0.92, right? Similarly, this 0.92, 0.08. They're all independent, so that's a nice thing here. Faulty saucer will be P, and this will be 1 minus P, right? Look at which branches that we need. So 140 first. Okay, let's deal with the 040. 040 is the easiest. 040 is essentially just no fault, right? So the 040 here will just be 0.08. Sorry. Faulty. Oh, sorry, I labeled wrongly. Faulty is 0.08. 0.92, 0.08, 0.92. So faulty, the other way around. So P, 1 minus P. This is 0.92, 0.92, 0.92. So essentially what we're getting is 0.92. Sorry, not 0.92. This is 1 minus P. Right, so this is 0.92 square. 1 minus P square for this branch. Right, that's it. Okay, this is done. Then we're going to go through the branches which contains 140 item. So we have 140, then if this is 140, then definitely the rest have to be non-40 here. So this is not an issue. Here it will be 1 minus P, 1 minus P. So this case here will be 0.08, 0.92, 1 minus P square. Okay, then the next one will be, this is for non-40, 40, non-40, non-40. So if I were to multiply this, 40 will be 0.08. This is 1 minus P, 1 minus P. So I will get 0.92, 0.08, 1 minus P square. Okay, then obviously this would be F prime, F prime, F prime. This over here, this will be, I'm just write this down nicely here. So 0.92, 0.92, P, 1 minus P. So the last one will be this 0.92, 0.92, 1 minus P multiplied by P, which is actually the same. So you put the times 2 there, multiply by 2 is fine, but it's actually just the same thing. So 92 square, then you put 1 minus PP. So these two can actually add up together, but this is 0.97, right? So once this is done, I'm going to just simplify it. So I could see that all this over here, 1 minus P square, I could add all this up together using calculator. Right, so I'm going to just sum this up for the 1 minus P square. Then the P multiplied by 1 minus P, I'll just sum it up as well. So just twice of 0.92 square. So here, once you're done, this is the required equation. Of course, I like to put the 0.97 to the other side. Now I'm going to key this into GC and solve for the P. Okay. So remember that just go to function y, then we just key in P is my x, so 0.99361 minus x square plus 1.6928 x 1 minus x minus 0.97. Okay, that's it. So what I would usually suggest students to do is you could see that x is between 0 and 1, so just zoom this 0 to 1. Okay, it doesn't seem like it cuts the x-axis, but we'll just see 1 and 1 here. Okay, so you could see that it cuts here. Great, so you can actually zoom in if you want to. Zoom box maybe. Okay, zoom box is good. Here is here, right? Yeah, there it cuts here. So I'm going to just calculate 0, 0, and after which I'm going to just put the other side. That'll be 0.06889. So there you go. So from GC, P equals to 0.06888913. So that's how I do this question proficiently. If you have any questions at all, please let us know and I'll see you in the next question.